So today's topic is, the first topic is fluctuations. So let us write down the first topic. We will cover two topics. The first is fluctuations. And their dependence on n. On n, where n is the number of particles. So when we say the fluctuation, it means that fluctuation from something. So what is that something? That something is the most probable state. Most probable state. So in any distribution, we have most probable state, and there will be certain probability for that most probable state, and then we will calculate the fluctuations from most probable state. From most probable state. So here we can calculate the probability for the most probable state, and here we can calculate the probability for the fluctuation. And then we have to correlate the both. We will correlate the both. Means we will calculate the relative probability. So relative probability means it is the probability of the fluctuation or the fluctuated state, and then divided by the probability of the most probable state. So that is the relative probability. So in one part we have to calculate the relative probability, and then we have to show that this relative probability depends on n. We have to show that this relative probability depends on n. N means the total number of the particles. And now we know that in the statistical mechanics, it is the importance of the larger number of the particles. Larger be the number of the particles, more less will be the fluctuation. So that phenomena, that fact we will prove in this exercise. So first we will take the example of the few numbers. So let us take the few number 40 and then 400. And before going to that, I will write the probability for the most probable state. And suppose we have n particles, so that probability is equal to n factorial and then divided by n by 2 factorial, n by 2 factorial, and then it is 1 upon 2 to the power n. So this is the most probable state, and we can also write this as p n by 2 n by 2. P n by 2. So this is the distribution, P n by 2 n by 2. So now let us take a number of particles as 40 and calculate the probability for the most probable state. Most probable state means P 2020. So what will be the value? This value will be 40 factorial and then divided by 20 factorial and 20 factorial and then 1 upon 2 to the power 40. So this is a very large number, and then I am writing the result directly, and this, or don't write calculate this, let us leave this as such, and then write the fluctuation or the state which is 25% off, 25% off from most probable state. So when I say 25% off from most probable state, means here the number is 20. So what is the 25% of 20? 25% of 20 is 5. So 5 off means now the distribution will be 25 and 15. If we have 40 number of the particles, then the most probable distribution is 20-20. This is the most probable distribution. And if I am writing the distribution which is 25% off from most probable state, it means 25% of 20. So that is the 5. So 5 plus and 5 minus. So 25 and 15. This is distribution. This distribution is the fluctuation which is 25% off. So what will be the value for this distribution? The value for this distribution will be 40 factorial and then divided by 25 factorial and then 15 factorial, and then of course there will be 1 upon 2 to the power 40. So now let us calculate the relative probability for this example. Relative probability. So relative probability means the distribution which is 25% off, that is 25 and 15, and divided by the distribution which is the most probable distribution, that is 20-20. So now when we will divide these two, then many things will get cancelled and the result will be 0.3. So I am directly writing the result, and note down this number and remember this number. This number is 0.3. 0.3 is the relative probability of the 25% of distribution when we have the total number of particles as 40. So when the number of particle is only 40, then for 25% of distribution or fluctuation, the relative probability is 0.3. Now we will do the same exercise for a large number. So let us take a large number, and that large number is 400. So now we have n is equal to 400. So for n is equal to 400, what is the most probable state? Most probable state is P 200 200. 200 200. So this is the most probable state. And now the probability for the 200 200, so that probability is 400 factorial divided by 200 factorial divided by 200 factorial, and then 1 upon 2 to the power 400. And now again we will write the 25% off distribution. 25% off distribution from most probable distribution or from most probable state. So 25% of 200 means it is 50. So what will be that? That will be P 50 plus and 50 minus. So it will be 250 and 150. 250 and 150. So the probability for this distribution, which is 25% off from the most probable distribution, that is 400 factorial divided by 250 factorial divided by 150 factorial, and then 1 upon 2 to the power 400. Now let us calculate the relative probability. Relative probability for this. Relative probability means the 25% off, that is 250, 150, and then divided by the most probable distribution, which is 200 and 200. So when we will divide all this thing, then we will get the result as 10 to the power minus 5. 10 to the power minus 5. So what we can calculate, or we can conclude from this, that when n is equal to only 40, then for 25% of distribution, in both the cases we have taken 25% of distribution of from most probable state. So when the number of particles is only 40, then the relative probability is 0.3, and when the number of particles is large, that is 400, then the relative probability is 10 to the power minus 5. It means that the larger be the number of the particles in the system, the more less will be the relative probability, or more less will be the fluctuation. So in this example we have taken the numerical value for the n. Now we will take a general case. So let us go a new page. Now we will take a general case, and for the general case, suppose we have the number of particles as 2n. Number of particles is equal to 2n. So the most probable distribution is PNN. PNN. This is the most probable distribution, or most probable state. And then we will take another distribution, a fluctuated state. And that fluctuated state is defined as, the distribution is n plus s and n minus s. We have 2n number of the particles, and the most probable distribution is nn, and then we have some fluctuation. So now the distribution is n plus s and n minus s. N plus s plus n minus s will be 2n, because the total will remain constant. This 2n will remain constant. So this is the fluctuated, and then we define the fluctuation as s by n. S by n is defined as the fluctuation f, such that f is very less than 1. So a small fluctuation from the most probable state. And now again we will calculate the relative probability. So the relative probability is relative probability R, and that relative probability is the distribution corresponding to n plus s and n minus s, and then divided by the most probable distribution, which is n and n. So now let us write this. And for this it will be 2n factorial divided by n plus s factorial into n minus s factorial, and divided by 1 upon 2 to the power 2n. 1 upon 2 to the power 2n, and this whole divided by 2n factorial, and then n factorial, and 1 upon 2 to the power 2n. So this get cancelled with this 2n factorial get cancelled with this, and we are left with n factorial, and then n plus s factorial and n minus s factorial. Now here you can see that n plus s is more than n. N plus s is more than n, and this n minus s is less than n. So we will expand this n plus s and n factorial in some manner, and that manner is that because n plus s is more than n, so n plus s factorial has some factors which will be aimed at n factorial, and from the starting it will be n plus s then n plus s minus 1, and then then this term will be n plus 1, and then n factorial. So do you get this point? Because n plus s is more than n, so when we factorize this n plus s factorial, then we will have the term like n plus s minus 1, then n plus s minus 2, and then up to n plus 1, and then n factorial. So this n factorial we can cancel with the top n factorial, and therefore I have written in this manner. So now come to the next factor, multiplication, and in the next factor it is the n factorial and n minus s factorial. So n minus s is less than n. It means that when we write the terms of the n factorial, we will have a certain term which will be equal to n minus s factorial. So here we will expand n factorial, not n minus s factorial, because n is more. So let us factorize this. So it will be n into n minus 1, then n minus 2, and at somewhere it will become n minus s factorial, and before n minus 1 s there will be a term like n minus s plus 1, and before n minus 1 plus 1 there will be a term n minus s plus 2. This term will be here, and then dot dot dot, and this whole divided by the n minus s factorial. So this will cancel many factors, because n factorial will get cancelled with this n factorial, and then this n minus s factorial will get cancelled with this n minus s factorial, and we are left with the terms as n minus s plus 1. Let us write in opposite direction. So it will be n. First I will write this n minus s plus 1. N minus s plus 1. The last term. So n minus s plus 1. This term. And then it will be n minus s plus 2 term. And dot dot dot. And then we have n minus 1 term. And then n. इसको रिवर्स ऑर्डर में लिख दिया है, and then divided by this whole divided by this will be also we will write this also in the reverse order. So here it will be n plus 1. Below n minus s plus 1 I have written n plus 1, and below n minus s plus 2 I will write n plus 2. Here the preceding term will be n plus 2, and then dot dot dot, and then the next term will be, this term will be n plus s minus 1, and the last term will be n plus s. तो इसको आप ग्रुपिंग करके लिखेंगे, एक एक टर्म के नीचे एक एक टर्म लिखेंगे, एंड देन अगेन वी विल मैनिपुलेट दिस. So again manipulate this. Now this n minus s plus 1 can be written as n plus 1 minus s. So let us write like this: n plus 1 minus s divided by n plus 1. So this is the one factor. And the second factor, n plus 2 minus s. So it is n plus 2 minus s, and then this divided by n plus 2. The second factor, and then dot dot, and then last term is, because here it is only n, so we will write it as, so let us write the just before the last term, that will be n minus 1, n minus 1, or let us write the last term. So that will be n plus s minus s divided by n plus s. So this is the last term. Now what we have to do, we will divide this n plus 1, this n plus 1 with this n plus 1, and then we will write it as, if we divide then it will be 1 minus s upon n plus 1, 1 minus s upon n plus 1. And in the second term again we will divide it by n plus 2, so it will be 1 minus s upon n plus 2, and then so on. And what will be the last term? Last term will be, we will divide it by n plus s, so it will be 1 minus s upon n plus s. So this is the last term. And because we have already taken s by n as the fluctuation, and this is very less than 1, it means that s is very less than n. S is very less than n. So in all these terms we can neglect 1 in comparison to n, 2 in comparison to n, and s in comparison to n. So what will happen here? It will be 1 minus s by n, and again the second factor will be 1 minus s by n, the third is again 1 minus s by n, and so on. The last term will be again 1 minus s by n, because we have neglected this 1, 2, 3, 4 up to s in comparison to n, because these numbers are very less than n. This we have already assumed, the fluctuation is less. So what are total terms? ये total terms कितने होंगे? These total terms we can count like this: 1, 2 up to s. It means the total number of terms are s. So it will be 1 minus s by n to the power s. 1 minus s by n to the power s. So this is our relative probability. Now we will go to the next page. So what we have derived in the last page, that is the relative probability is equal to 1 minus s by n to the power s. Now take the log of both sides. So it is ln log of r is equal to s into log of 1 minus s by n. 1 minus s by n. And then we can expand this. We can expand this log 1 minus s by n. So there is one formula that we can expand log 1 minus x. You might have studied this in mathematics, and when x is very small, then it can be expanded. It can be expanded like minus x square minus x cube and so on. So it will be minus s by n. If we expand the 1 plus x, and here the value of x is minus s by n. So it is like minus s by n, then minus s square by n square, then minus s cube by n cube, and so on. So there are various terms. Now let us multiply it by s, then it will be minus s square by n, then minus s cube by n cube, and so on. So because s by n is very small number, and therefore we will retain only up to the first term, and then it can be written similar to approximately minus s square by n. Minus s square by n is equivalent to minus s square upon n square into n. So n get cancelled, and we will again have s square by n. And this is fluctuation, minus f square n. So this is the fluctuation. So we have derived the equation that ln r is equal to minus f square n. Therefore the relative probability is equal to e to the power minus f square n. Relative probability is e to the power minus f square by n. So what is the probability distribution? Probability distribution. Pf for the fluctuation f. Because this is the relative probability, so to write the probability distribution, we can multiply it by a constant c, and therefore it will be c some constant into e to the power minus f square into n. So this is the probability distribution C e to the power minus f square n. And now we will calculate the value of this constant because the total probability is 1. This we know that the total probability of any distribution, probability of any distribution is equal to 1. So if we integrate the pf within the limit -1 to +1 df, df पे इंटीग्रेट करेंगे इसे, तो फ्लक्चुएशन कितना हो सकता है -1 to 1, मतलब कंप्लीट फ्लक्चुएशन, एंड दैट शुड बी इक्वल टू 1. और इसे जब आप इंटीग्रेट करेंगे देन यू विल गेट c इज इक्वल टू √n/pi, n/pi. So what is the value of pf? The value of pf is equal to √n/pi into e to the power minus f square n. So this is the probability distribution. For any given fluctuation f, the probability distribution is √n/pi e to the power minus f square n. So we see that this depends on the n. The probability distribution depends on the n. Now if we plot a curve for the distribution, x-axis and the y-axis. On the middle, because we have to write the fluctuation on the x-axis, zero fluctuation means, what is the meaning of the zero fluctuation? It is the most probable state. When the fluctuation is zero, it means that at the zero fluctuation, when fluctuation is zero, then we will have the most probable distribution or most probable state. So f more than 0 or f less than 0 for both the case. So the equation, the curve will look like this distribution function. So I have drawn here the 3 curves, and these 3 curves show that at zero fluctuation means the most probable state. So at zero fluctuation, the probability will be maximum. Here it is the probability. On the y-axis, it is the probability, pf. So for all the cases, the probability will be maximum when the fluctuation is 0. When the fluctuation is 0, then probability will be maximum, and this is the maximum point. And then this curve is for the larger number of the particles, 10 to the power 10. Let us say it is 10 to the power 10 particles. N is equal to 10 to the power 10. And here it is n is equal to 10 to the power 8. And here it is n is equal to 10 to the power 6. So this is the distribution function. Because the most probable state, that also probability depends on the n. It depends on the n. Therefore, it will change with the n. This point will change with the n. And we will see that for the larger number, the distribution is narrow. And for even more number, the distribution is wide. And then for less number, it is more wider distribution. So this is about the distribution function. Now if anyone has any query or any doubt, then you can ask about this topic. Switch on your mic and ask. If you want to ask anything, then you can ask related to this topic. And if there is no query, then I will proceed further. And then I will cover one more topic today, and that topic is the division of phase space into cells. Division of phase space into cells. So let us go to a new page and write down the next heading. And next heading is the division of phase space into cells. So if we have a six-dimensional phase space, phase space, six-dimensional phase space means it is the mu space. It is the mu space. Then what are the coordinates? We have the coordinates dx, dy, dz, then dpx, dpy and dpz. So these are the six coordinate system in the mu space. Now we have a, Heisenberg uncertainty principle, which states that x delta x into delta px, that should be of the order of h, and similarly delta y into delta py, that should be of the order of h, delta z into delta pz, that is of the order of h. This is Heisenberg uncertainty principle. Uncertainty principle means this will be greater than or equal to, this will be greater than or equal to h. So now I am taking equal to h. Then what will happen? This volume, the total volume, this is the total volume of the phase space. The six coordinates, the product of the six coordinates represent the total volume of the phase space. So this can be grouped as dx into dpx, and then dy into dpy, and then dz into dpz. So all are equal to h. All these are equal to h. So the minimum volume for any cell, minimum volume for any cell, or cell with the minimum volume has a volume equal to h cube. The minimum volume is h cube. So what will be the number of cells? What will be the number of cells in the phase space? In the phase space, that is the total volume, that is the total volume, and this total volume divided by the volume of the smallest cell, volume of the smallest cell. And total volume means total volume is equal to dx, dy, dz, and then dpx, then dpy, then dpz, and this whole divided by the volume of the smallest cell, which is the h cube, divided by h cube. Now this dx, dy, dz, this is the ordinary volume. Ordinary volume. When we say the volume, then ordinary volume means it is the length into breadth into height. So that dx, dy, dz will give the ordinary volume, and then dpx, dpy and dpz divided by h cube. Now when we will write the total volume, then we will have to integrate these for 6 times. 6 time integration over dx, integration over dy, and so on. And when we take the integration, 3 integration over dx, dy and dz, then this will give the normal volume v, and therefore we are remained with let us open this again. And here again there will be three integration over dpx, dpy and dpz. So the number of cells is equal to V ordinary volume, and then 3 integration over dpx, dpy, dpy and dpz, and this divided by the h cube. So these are the number of cells in the phase space. Now we will proceed further and go for a question. You can write the question in the, we will solve this topic by the in form of a question. So let us write a question. For a single particle, note down in your notebook, for a single particle, for a single particle of mass m, calculate the number of microstates, calculate the number of microstates within the range 0 to e. So here E is energy. E means it is the energy of the system. For a single particle of mass m, calculate the number of microstates within the range 0 to E, where E is the energy. So because here only one particle, therefore the number of microstates will be the number of microstates will be the number of cells. Why this is so? Because there is only one particle, and if we have suppose we have 100 cells. If we have 100 cells and there is only one particle, so one particle can go in the first cell, second cell, third cell, fourth cell and so on. It has the 100 varieties. This particle has 100 options to go in different cell, because there is only a single particle, and because in 100 options, it means there are 100 microstates, and this 100 particle corresponds to a macrostate, and 100 options for a single particle means 100 microstates. It means the 100 microstates means 100 cells. So for a single particle, number of microstates is equal to number of cells. So we will write the number of cells. And what is the number of cells? Number of cells is 6 times integration over dx, dy, dz, then dpx, dpy and then dpz, and this whole divided by h cube. Now the three integration over dx, dy, dz, this will give the ordinary volume. So ordinary volume divided by h cube, and then the remaining three integration over dpx, dpy, dpz. So this volume is like the volume of the sphere of the momentum p, and that will be 4 pi by 3 into p क्यूब. जैसे हम सिंपल वॉल्यूम लिखते हैं, अगर सिंपल वॉल्यूम हम लिखेंगे तो उसमें कैसे लिखते हैं? This is the circle, and if this is the radius, then what will be the volume? Volume will be 4 pi by 3 r cube. So here in this integration, this r is the momentum. This is the momentum sphere with the radius p, and therefore the volume is 4 pi by 3 p cube. So what is the number? It is v, it is 4 pi v divided by h cube, 3h cube, 4 pi v divided by 3h cube and then p cube. But in the question, it is not given the momentum range, but it is given as range 0 to E. Means we have to report our answer in terms of the energy. So what we will do? We will change this P into E. We can change this P into E. So let us change the P into E. P is the momentum and E is the energy. So what is the relation? Kinetic energy. E is the kinetic energy. So the relation is that kinetic energy is equal to P square by 2m. P square by 2m, and that is equal to E. P square by 2m is equal to E. So P square is equal to 2me. 2me. And therefore P is equal to under root 2me, or this is equal to 2me to the power half. To the power half. This is the value of P. So let us substitute this value. So it is 4 pi V upon 3h cube, and the value of P, which is 2me to the power half and then cube. Therefore it will become 3 by 2. 4 pi V upon 3h cube into 2me power 3 by 2. So this is the number of the microstates, and we can write it as phi E. The number of microstates, we can write it as phi E is equal to 4 pi V divided by 3h cube into 2me to the power 3 by 2. So this is the answer of the question. Now let us take another question and go to the next page. A similar question, and now write another question as for a single particle of mass m, calculate the number of microstates in the energy range E to E plus dE, E to E plus dE, E plus dE. Now open your mic, switch on your mic and tell me what is the difference between the two questions. What is the difference between the two questions? माइक ओपन करके बताइए. हाँ, कोई भी माइक ओपन कीजिए और बताइए कि दोनों क्वेश्चन में डिफरेंस कहाँ पे है.
मैम डिफरेंस में एनर्जी रेंज में है.
हाँ, नाम क्या है बेटा तुम्हारा?
गौरव मैम.
Gaurav, good. The difference is in the energy range. In the first question was asking that calculate the number of microstates in the range 0 to E, in the energy range 0 to E. But in this question, it is the energy range E to E plus dE, E to E plus dE. So this is the difference. Now we will take the answer of the first question, which is the phi E. The number of microstate for in the energy range 0 to E is 4 pi V divided by 3h cube into 2m E to the power 3 by 2. So this is the answer of the first question. Now here it is asking deba phi over deba E. within the range E to E plus DE means within the range deba E. So now we have to calculate deba phi E upon deba E. So let us calculate this and tell me the answer. इसको अपनी कॉपी में कैलकुलेट करके बताइए कितना आएगा. सब लोग अपनी अपनी कॉपी में कीजिए. इट इज इजी डिफरेंशिएशन. 4 pi v upon 3h cube. This is a constant term. Then differentiation of 2me power 3 by 2. So this will be 3 by 2 into 2me to the power 3 by 2 minus 1, that is half, and then multiplied by differentiation of 2me. Differentiation of 2me means 2m into dE. 2m into dE. So let us manipulate this. So this 2 get cancelled with this 2, and this 3 gets cancelled with this 3, and then we are left with 4 pi v divided by h cube, and this under root 2 m to the power half, and this m means it is m to the power 3 by 2, and this e which is e to the power half, and this dE. So this is the answer. 4 pi v upon h cube under root 2 m to the power 3 by 2 e to the power half and dE. This is the answer. Means number of microstates in the range e to e plus dE. Now we can solve this in another way also. So let us do it in another way. So deba phi e upon deba e. This is equal to volume V divided by h cube, and then 3 integration over dpx, dpy and dpz. ये जो पहला इक्वेशन था फंडामेंटल इक्वेशन, वहीं से लिया हुआ है इसे. ये जो शुरू में लिखा था डिवीजन ऑफ द फेज स्पेस. सो इट इज v अपॉन h क्यूब, एंड देन वी हैव लेफ्ट विद द 3 integration over dpx, dpy and dpz. Now if I say the range of the momentum from 0 to p, then the 3 integration over dpx, dpy and dpz, these 3 integration represents the volume like this: a sphere with the radius p, a sphere with the radius p. If I take the range from 0 to p, then the volume of the momentum space is equal to the volume of a sphere in which the radius is represented by p, and that volume is 4 pi by 3 into p cube. The volume of the sphere, 4 pi by 3 into p cube. Now in a case when we say the volume of p space or momentum space within the range p to p plus dp, then what portion we will consider? P plus dp means it will be like this. So this is the sphere of the radius p, and this is the thickness dp. So p to p plus dp. The inner circle or inner sphere has the radius p, and the outer sphere has the radius p plus dp. And it is asking the volume within the range p to p plus dp. It means here it was this volume, the complete volume for 0 to p. But now we have to calculate only this volume for p to p plus dp. And what will be this volume? कोई बता सकता है ये वॉल्यूम कितना होगा? गौरव, what will be this volume? या कोई और बताइए. What will be the amount of this volume, the shaded portion? you can calculate in a manner as P plus the volume of the outer sphere, that is 4 pi by 3 P plus dP whole cube, minus the volume of the inner sphere, that is 4 pi by 3 P 4 pi by 3 P cube. And if you do that, then neglecting dP cube and dP square terms, you will get the volume as 4 pi P square into dP. So this is very simple. In statistical mechanics, you will get this type of problem many times. So the volume is very simple. Take the surface of the sphere of the P radius, which is 4 pi P square. This is the surface area. 4 pi P square is the surface area, and then multiply it by the thickness. So surface area into thickness, this will give the volume. So the volume is represented as 4 pi P square into dP. So now what I will write here, I will write here V upon H cube, and this volume is 4 pi 4 pi P square into dP. 4 pi P square into dP. Now here it is dP, and we have to report in terms of the dE. So we will change the dP into dE. How we can change the dP into dE? Because we have the relation P square by 2m is equal to E. It means P square is equal to 2me. P square is equal to 2me. So let us differentiate this equation. So this differentiation will become 2p into dP is equal to 2m into dE. So what is the value of dP? The value of dP is equal to 2 get cancelled. dP is equal to m upon p into dE. M upon p into dE. So let us substitute this value. So it is V upon H cube and then 4 pi P square, and instead of dP write m by p into dE. So this p get cancelled, and then we have 4 pi V upon H cube and then p, only p. And what is only p? Only p is equal to under root 2me. So 2me to the power half p, and then m into dE. So we will get the same answer which is here, that is 4 pi V by H cube, and then this under root 2, and this m into m means m to the power 3 by 2, and then this e to the power half into dE. So we can solve this question in these two different manner, but the first is easy. Because we have already calculated this portion we have already calculated, therefore this is easy. But if you start with the fresh question and you don't have this part, then you can proceed in this manner also. So this is about the division of the phase space into various cells and the calculation of the microstate. The very important thing in this question, a very important point in this question is the single particle. The single particle, this is a very important fact. अगर single particle नहीं होगा, then we cannot write the number of microstates as the number of cells. Then the method will be different. So this is only for the single particle. Now if you have any query or any doubt, you can ask. And if no query, then you might have written your attendance in the chat box. So now let us stop this.